Hello students, let's start the KCT integral part. It's a concept video. One again a very important and a very beautiful topic. Okay. Now in order to do this topic, first let's understand what's the importance of this topic. If you want to know the importance of the topic, you can judge it by this statement that per year almost around 5 to 6 questions you can expect from this chapter. So 5 to 6 is itself a very big number in KCT. So it's very important. Now in order to solve this chapter in a very easy manner and a very good manner so that you get all of the 5 to 6 questions, what you need to do? The basic and the pretty basic thing is first the formulae. Okay. So these formulas are my first line of defense. Okay. Once I'm done with the formulae, second thing is what? Now, what happens is a lot of questions will be very similar to POC. But the second important thing is in the part, what is the next important thing is it is similar to your POC, okay, or class 12th one for the CBSE students, but you have to solve that question in less than 30 seconds. So do you imagine solving a partial fraction question or a big UV by parts question, okay, in less than 30 seconds? So you need to use the tips and tricks, okay, to solve those questions. Okay, so that will be coming with the PYQ section. In this section we'll be learning the formulae that is needed. Now what happens is a lot of times we want the formulae in one proper manner, okay, in a concise and in a proper detailed manner so that we don't have to look for each and every formula. So here in this topic, what I've done, concept video, I've given you each and every formula of the indefinite plus the definite plus extra whatever was needed going through the past KCET questions from 2014 to 2020, whatever the extra formulas, tips and tricks, whatever extra things we needed, like so that you can solve the questions in a much easy manner, I've given you all. So that is one part of it. Now, apart from that, in order to solve it in more efficient way, while doing the question, I'll be able to show you and explain you in the PYQ section. So this will be like a small lecture, just telling you which are the very important formulas, which you definitely need it. Now, this chapter, student, is very linked with the trigonometry. So if you haven't memorized the trigonometry formula from your 11th and 12th, then it will be a bit difficult for you to do this chapter in less than 30 seconds. Now you'll say, sir, we are doing this chapter integrals. Why do we need that much of trigono? Why do we need that much of trigo? So trigo here plays a very vital role. A lot of places you need to understand the moment you see the question, oh, here we have to apply the substitution. So you need to know the trigonometrical substitution. Okay, you need to understand, okay, this trigonometric formula, if I use it, I'll be able to simplify in much better way. If I know sine of 90 minus theta is cos theta, or if I know sine of 2 pi minus theta is what, I can apply the definite rule in much better way. So you need to know all this stuff in order to solve this in a much better way. Along with that, you need the concept of area part. What are the different, mensuration formulas, along with AOD formulas. Okay, so all the chapters which we have done previously, you need to know all of them. Now let's start the chapter, finish the formulas. This you write it down, make a note of it. So while solving the PYQ, you can refer to them properly and you can mark the ones which are very important and keeps repeating. So you can mark them, you can write multiple times and you can memorize in such a way so that you don't do a plus minus mistake also. Okay, and in the previous video of continuity and differentiability, I have already explained the importance of having your formulas very strong. Okay, the importance of having a strong formula background. Okay, so if you remember the formulas properly, so the moment you need it, you'll be able to use it. What happens is sometimes in order to recall, we take a lot of time. That recalling time we don't have while solving a KCT question because you just have a time span of 30 seconds. So students, imagine, let's say you are in the exam center, you're sitting and you're thinking that this question looks very similar, and if I apply this trigonometrical formula, I'll be able to use it. Okay, but there what happens? You're not able to recall the exact formula. So will you sit down and derive the formula? Done. So that question will be gone. So try to make your formulas very strong. Okay, memorize them, write it down. Okay, and we'll give you tips and tricks where you will be not using much of the formulas, and you'll be using what you say with the tips you'll be able to solve it much faster way, but still the formulas background has to be very strong. If you really and dedicatedly want 50 plus out of 60 in KCT, you need to have a very solid formula background. Okay, so don't neglect it, since it is mostly based on the formula. Stop the video, write down each and every formula, memorize it thoroughly, rewrite it, practice by rewriting. It will help you a lot. Okay, and these formulas will be like your pretty much basics, okay, for your AOI part, application of integrals. Okay, now let's start the chapter. Now we all know this formula, integration of x power n dx. Okay, we know integration of 1 by x, integration of e power x, very important. A power x, integration of just dx, sin x, cos x, secant square x, sec x tan x, cosecant square x. So these 10 formulas minimum everybody knows, correct? Along with that, we know this cot x in terms of this, tan x, secant x, cosecant x. We know these 14 formulas, we know minimum. Okay, now again the 15th one also we know, we use it a lot of time. Inverse, all this I know. So we also know this, we know this formula. Now these are till 20, these are pretty much the basics, trigo, integrated formulas, and inverse. Okay, inverse of the trigonometrical function. So these 20 formulas should be on your fingertips, very important. Nothing is there in this. Okay, just formulas, so do write it down, but you need to understand where is minus, where is positive. Okay, so see, sine inverse, here we have a positive part, here we have a negative. One wrong in the sign, you get a laddu and bring home. Okay, so one wrong means you lost a very easy 1 mark, and that 1 mark can cost you around, if you're playing in the upper zone of the rank, around 1000 rank. Okay, so try not to do like that kind of mistake. Okay, so your formulas are very, very, very important, don't neglect it. Now coming to this, which are some are like very important formula. Now this is a very one of the most and used formula in KCT part. See, whenever you have a function and its derivative you have. Okay, so let's see an example and do it. So let's say I have a function, have integral secant square x by tan x dx. So what I'll do, the moment I see, okay, I remember d by dx of tan x is what? See, here the derivative formula is also used. D by dx of tan x is what? I have taken tan x as t. D by dx of tan x is secant square x. So secant square x dx is equal to dt. So what will happen? This will be, if I take this as t, this whole thing will become dt. So integration of dt by t. Correct. And that is equal to what? Log of t plus c. That's it. So see how easily we solve this question. So a lot of questions, even the polynomial function, very similar to this, like you say integration of, here we have 2x plus 4, and here we have, what do you say, let's say x square plus 4x plus 3. So directly the moment you have taken this as t, this whole thing becomes dt. So done. So substitution plays a very vital role and very important. So this should be in your mind. Okay. Now along with that, sometimes when root comes, same this question 2x plus 4 and given in a root form x square plus 4x plus 3. If I take the inside one as t and this one as dt, so I'll get in the form of 2 integration of root fx plus c. So I've given you the shortcut formulas which you can use. See here, so I have taken tan x as t. So what will happen? So what will I get? dt by root t. And if I do the integration of this, now anybody who has difficulty in the basic integration part, okay, you can put it up. We'll try to take each and every formula. Again, we are coming back each and every formula, and we'll try to give you the pretty basics, since it is a crash mainly made for KCT part. So we are not giving you the pretty basics like how to apply this formula integration of x power 5x dx. Okay, so that at least I can expect all of the students, they know that much. Okay, so we are not giving you that one, not giving you the examples on that pretty basics ones. Okay, now so this part you can mark it as this is important. Okay, you should understand. Now these again special integrals, you should remember it. Nothing is there much to explain here. Again, now while understanding, while memorizing, you write one part of the formula like this side and the other part here, so that you can compare. Okay, in this one I have something extra like this, so you can understand and you can do it like memorize more better. Okay, now next is this one by parts. whenever we have integration, two functions we have. Let's say we have x and we have integration of sine x. So one is my polynomial function, okay, or you can say algebraic function, and the other is my trigonometrical function. So I have these two functions. So which one function will go as u and which one will go as v, that I'll use by this order, ILATE. I stands for inverse, L stands for logarithmic, A stands for algebraic, T stands for trigonometric, and E stands for exponential. Okay, you can use all this and you can select whichever functions, and then the integration formula is first function whichever you have taken, integration of the second function minus derivative of the first function, integration of the second function, and then the whole integration dx. Clear? By using this one, now how to solve in a much smaller and a much better way, we'll show it in the PYQ section. Okay, so don't worry about that, we'll show you everything there. Now again, integration of e power x, when we have a function fx and its derivative is already there. Now they won't give you a pretty simple what I've taken here, like e power x integration of tan x plus secant square x, and you take this as, this will be your fx and this is your f dash x, okay, and then the integration will be e power x fx plus c, correct? So they won't give you this simple and easy formula. They'll give you fx and f dash x in such a way so that you have to simplify and bring it to that form. Okay, so we'll show you how to simplify and how to bring it in that form. Coming to this, these two formulas are also very important. Whenever you have integral of e power ax sine bx, that is equal to e power ax by a square plus b square, and then a sine bx minus b cos bx. Now what is the difference with the cos verse? In the cos part, this part remains same. Okay, what changes here? Here a cos bx happens plus sin bx. So sin changes and the sin is changed to cos and the cos is changed to sin, that's it. Okay, now again this is the application of the previous formula which we learned, integration of f dash x by fx dx here, but it is not direct. Here we have to arrange it. This numerator is not exact derivative of the denominator. So what we do, we write numerator is equal to lambda times of d by dx of denominator and then plus mu, and then we adjust them and find the values of what, p and q, and we solve it. Okay, now this substitution for the partial fraction, we need it, very important. Okay, whenever we have something like 2x plus 3 integration x minus 2 x minus 3, so this whole thing we can do as a by x minus 2 plus b by x minus 3. Now we can solve, we can find the values of a, let's say a value and b value, and then we can integrate simply. Okay, so let's say 2 by, I'm just taking a random value, I'm not solving it here. Okay, and then you can integrate. So just I'm showing these formulas are very important. While solving the PYQ, we'll show you how to solve it, how to apply it. Now coming to the most important part is the properties of definite integral. Now how to use these properties? Very simple it is. This is the basic definition. Whenever you have integration and then you have limits from a to b, the integration is basically what they're trying to say is you're trying to find the area from where to where, area of this curve fx, from where to where, this concept we will learn in the area section. This concept we'll learn in the area section. Basically we are trying to find the area from a to b of this fx region. Okay, now that is equal to integrate it and then put the, what is the upper limit minus lower limit. Let's see one question, integration of x power x square dx. So what is integration of x square? X cube by 3, correct, and we have upper limit 2, lower limit 1. Put the value first, the upper limit, so it will be what, 2 cube by 3 minus the lower limit 1 cube by 3. So what we will get, 8 by 3 minus 1 by 3, and that is equal to what, 7 by 3. That is our answer. Now what is the second property? Very simple property. If you have an integration from 2 to 3 fx dx, that is nothing but minus of 3 to 2. You change the limits, you'll just get a minus sign, that's it. Clear? Now this third one is very useful. This third one is very useful in solving questions like this. Okay, let's say I'm integrating it from minus 2 to 2, but my mod x is changing. Okay, my mod x is like this, correct? So from -2 to 0 it is the negative this line, and from 0 to 2 it is this line. So what I'll do, I'll break it. From -2 I'll go till 0 fx dx, and then from 0 to 2 I'll go fx dx. Okay. So this is very important for the case of like mod where the function is changing in between regions between the limit part. Okay. So what we do, we break it and integrate from a to c and then from c to b. So basically I have an curve like this. So instead of integrating the whole thing, okay, I'll first integrate from a to c and then I'll go for a to b. So basically you will understand more better if I have a function which is changing like this and this. Okay. So let's say this is a, c and b. So a to c it has a different equation and c to b it has a different. So it's very easy. Okay, and in that case scenario we apply this formula. A to c, since the function value fx was different, so a to c we will integrate by this fx. Okay, and from c to b there was a bit change in the fx, so we'll do by this f dash x dx. Okay, done. Not dash, you can say it as g dash gx. Okay, clear? So very simple. So we use this. So very easy for the integration part. More application will show you in the PYQ section. Now this formula again very important. Whenever we have integration of a to b fx dx, this property very important. What we can do? We can use it as first top plus bottom minus x. Now understand this. This is very important for trigonometrical. Now how? Let's take an example. Integration of 0 to let's say pi by 2 sin x dx. So can I write it as integration of 0 to pi by 2 sine of 0 plus pi by 2 minus x. Now let's say that is equal to 0 to pi by 2. Sine of 90 minus x is what? Cos x. And let's say they have given this as a question and this is an answer. So directly I can answer, okay, 0 to 2 sin x dx is nothing but 0 to pi by 2 cos x dx. Correct? That's it. So these kinds of concepts we'll be using a lot. Same thing, instead of b we have from 0 to a. Okay, instead of a we have from a to b. Okay, so both are same. Like here also you can take it as this is pi by 2 and this as what you can take it as pi by 2, or you can better is a to b. No, so what we can do, we can take it as don't take that as a function. What we can do is we can just integrate from pi by 2. Yeah, we can take pi by 2 to pi by 2. Okay, we have this formula also, so we can use f of pi by 2 plus pi by 2 minus x again for the trigonometrical part. So basically f of pi minus x, we can use this also and we can do it. Okay, now whenever we have like something from minus a to a, whenever we have something like from minus a to a fx dx, so what we can do, let's say we have a sin x graph. Okay, and we want to integrate it from pi by 2 to minus pi by 2. So minus pi by 2 is negative like this. So what we can do, instead of this part we have here and this part we have here. So what you can see this part is positive area and this part is negative. Correct? So if I add these two, what I'll get? I'll get 0. So we need to understand what is an odd function and an even function, and we can solve it very easily. Okay, let's understand this with an example. So let's say I'm just explaining this. I have from minus pi by 2 to pi by 2. The first case scenario is sin x dx. Now I know whenever I have a function fx is equal to sin x, if I put f of minus x, what I'll get? Minus sin x. So it is coming in which category? It is an odd function. Whenever I am putting f of minus x, what happens is it just rejects it out and it gives me f of x. So you can understand this and you can remember it like this. Whenever you put a negativity to this kind of student, what it does, it just throws out the negativity. Okay, odd function is like you put negativity to them, they'll just throw it out. Okay, they won't take it inside. Okay, they won't absorb that negativity. So we need to be like this kind of people. Okay, this kind of person. So we got f of minus x is equal to minus sin x. Correct. So whenever we have something like this, so 0 to pi by 2 or basically minus pi by 2 to pi by 2, what I can do, f of x dx will be equal to what? 0. Now I'll say, sir, is there any other way you can explain? Yeah, you can see, you can use this also. There's minus. So can I do from minus pi by 2 to 0 sin x dx plus the other property 0 to pi by 2 sin x dx? Correct. Now you'll see this part is negative and this part is same but positive and equal. So if I add these two, what I'll get? 0. So the moment I'm able to identify that the function is odd, directly I can put the answer as 0. And if I know the function is even, see in case of cos. So in case of cos, let's say we are taking from minus pi by 2 to pi by 2. So cos is like this. So both part is what? Positive. Positive. So instead of integrating the whole thing from minus pi by 2 to pi by 2, cos x dx, what we can do? We can just integrate from 0 to pi by 2 and double it, cos x dx. That only they're telling. Instead of integrating this separately and this one separately, you can just integrate, let's say, this first half and double it into 2. Correct. So that only that is given here. So we need to understand even function is a function which can absorb the sign. So we know cos of minus theta is equal to cos theta. So cos is an even function. Sine is an odd function. Okay. Clear? Students, a bit issue is there. My voice is like a bit, not going properly while recording the videos. So much on a faster scale. Okay. So do bear with it. Okay. If you have any doubt, any difficulty with the understanding the audio, put it on the comment section. We'll try to do whatever we can best so that you are not in a difficult position to understand the video. Okay, to understand the topic. Now coming to the very simple thing again, if you see a graph and we want to integrate, let's say, sin x from where to where? 0 to 2 pi. Okay, so if I want to integrate sin x from 0 to 2 pi, what I can see is this part is my positive, and exact whatever the value I get here, the same exact I'll get it downward. So if I know that, okay, sine is what? A function where f of 2 pi minus x is equal to what? F of 2 pi minus x is equal to what? Minus of fx. If I can understand that, what I can do? Directly I can put the value 0. Correct. So if I know f of 2 pi minus x is equal to fx, then it will be that what? Double of that. So it's very simple, students. Okay, basically what we are doing is 0 to 2 pi, we're just breaking it into two parts. One, the function fx, and the function f of 2a minus x. If both these two functions are equal, then what we can do? Directly we can write 0 to a to f of x dx. And if they're opposite and equal but negative to each other, directly we can put there 0. Okay, so you don't have to take pressure while solving the PYQ. With each and every question we'll explain you in detail. Okay, so this is the pretty much ending of the integral. All and every each and every formula is concised and given to you. You don't have to search any other place, any other channel for any other formula. First thing. Second thing is no books you have to use. We have used Exemplar, we have used R.D. Sharma, we have used NCERT, we have used KCET, Dinesh and other publications, and we have went through the previous years from 2014 to 2020 PYQ, so that no formulas or anything is skipped. Okay, from our side we have done whatever we can do. So do make a short note, and these short notes you can upload in our website onlinesamclasses.in. You can send it in our WhatsApp group. Okay, the link is in the description. You can give it in the Telegram channel. Okay, now you can also follow us on Insta. You can also follow us on Facebook. Okay, so as of now, whichever way you can contact us, our number is also given. We take calls. Whatever doubt, difficulty you have, you can put up all there also. Okay, so whichever way we can come to you, we can reach to you, we have done. Now it's on your duty. If you think that whatever we are doing is good and it should reach to all the students, do like, share and subscribe, and share it to whatever people or student you think they really require it. They don't have the money to read, they don't have the money to go to a very good coaching center, so you can just provide it to them. We are bringing each and every chapter, and we are giving it absolutely free of cost. So work hard. Only thing what we require is honest dedication and hard work. That's it, student. Okay,